All right, hi guys. Today we are going to take some notes. So this is April 13th, and this is how to solve an exponential equation using a logarithm. So, when do I need to use a log to solve an exponential equation? So, essentially, yesterday we learned how to solve exponential equations when you don't need to take logs. And today I'm going to teach you how to solve an equation when you do. So it says, when do I need to use a log to solve an exponential equation? So I'm going to put here, not needed versus yes needed. Okay, and I'm going to do a not needed one first, which is what we did yesterday. So for example, solve for x, and I'm going to put 8 to the 2x equals 16 to the x plus 1, and we're going to solve for x. So in this case, the reason a log is not needed is because we can rewrite these two expressions with a common base. So what I'm going to do, I'm going to write that here. Rewrite with a common base. So the way I do that is, we practiced this the other day, 8 and 16 share a common base, which is 2, right? So I can rewrite 8 actually as 2 to the third. So that's 2 to the third. And then it's still raised to the 2x, right? Put that in parentheses. So I have 2 to the third to the 2x equals, and then 16 is actually 2 times 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So I can write this as 2 to the 4 to the x plus 1, okay? So now I have common bases. My common base is 2, right? So they both have a base of 2, which means now what I can do is I can basically ignore the base and set the exponents equal to each other. So what I'm going to do is I'm going to set the exponents equal to each other. So this, 3 times 2x equals this, 4x plus 1. And now it's just a matter of solving. This is just basic algebra. So this is 6x equals 4x plus 4. Subtract this to both sides. So I get 2x equals 4. Next I divide by 2, and I get x equals 2. Okay? So this is when a log is not needed. This is a review of what we did yesterday. Okay, now I'm going to give you an example of when it is needed. So put some lines here. Now I'm going to do this. We're going to solve for x in this equation. 5 to the x equals 12. So I'm looking at this and I'm like, is there a possible way that I can rewrite 5 and 12 with a common base? And the answer is no. So what am I going to do? I'm going to take the log of both sides. So it looks like this. Log of 5 to the x equals log of 12. So now when I have log of 5 to the x equals log 12. Now I'm going to use a rule, which is this. Log of x to the a, where a is my exponent and x is my number here, is the same thing as, and what you can do is bring the exponent down to the front. So this is the same thing as a times log x. If you're taking the log of something that has an exponent, it's the same thing as multiplying that exponent times the log. So I'm going to use that right here. And I'm going to bring this x down to the front. So it looks like the following. X times log 5 equals, and this is the same thing, log of 12. Okay, now what am I going to do? Well, this is multiplication, right? And whenever you need to get rid of multiplication, what you do is you divide to cancel. So I'm going to divide both sides by log of 5. What I'm going to be left with here is just x. On this side, I have a log divided by a log. Here is where our calculator comes in. So everybody's going to need to get a calculator. I'll give you a moment to get a calculator. Okay. Here, what we're going to do to find log of 12, I'm going to use my calculator and type, find the log button. Anybody see it? Here it is, right here. Log of 12 equals, and it's going to be a decimal. Now, why is it this decimal? Well, really, if log doesn't have anything written here, there's no base, you know it's a base 10. So 10 to this exponent is going to equal 12, and I'll prove it to you. 10 to the 1.079. So 10 to the 1.079 should be almost 12. And it is. The reason it's not perfect is I rounded this. But that's what we're doing here. So log of 12 is equal to this. So I'm going to write that down here. Divided by, and now I'm going to do the same thing with 5. So log of 5 is this. And now just to check it, I'm going to raise 10 to this power to see if this is the exponent. That would get me 5. So 10 to the 0.69897, 69897. Okay, so 10 to the 0.69897 should give me about 5. And it does, right? Super close to 5. So divided by log 5, which is this. I'm going to write this down. And now I simply do this division. Now, on the calculator, it's honestly better to write this. Log 12, parentheses, divided by, so that's this, log 12 divided by log 10, like this. Oops, I did the wrong thing. Sorry. Log 12 divided by log 5. So it's 5 here. Here's going to be my answer. 1.54395. So my answer for x is 1.5439. This 5, I'm going to round to be a 6, so 6. And since it's not perfectly equal to that, I'm going to write an approximate symbol. Okay? And the last thing I'm going to do is I'm going to check it. So let's check and see if it's right. Does 5 to this value equal 12? Check. 5 to the 1.5436. Let's do that on a calculator. 5 to the 1.54396 equals, oh, look at that, 12 with some decimals at the end, but that's because I rounded this exponent. So it does equal 12, and I'm good to go. Okay, that's it. So what did we do? If you're looking for an exponent and you can't turn it into the same bases like we did here, all you do is you take the log of both sides. Use the rule where you bring the exponent down to the front, divide both sides by the log, and you're good to go. I'll show you a couple examples on your worksheet, classwork 78, and then you should be good to go. So this here is our worksheet, and let's do this first one. Okay, so 3 and 17 don't have a common base. So first I'm going to take the log of both sides. So I go like this. Log of 3 to the b equals log of 17. Now, number 2, I can use the rule that log of x to the a equals a times log x. So I basically bring this down to the front like this. So now I have b times log 3 equals log 17. Notice this hasn't changed at all. Now, to get the b alone, I'm going to divide both sides by log 3, log 3. This cancels, so I get b equals. And then on my calculator, all I do is log of 17 divided by log of 3. Notice how I'm putting these parentheses here, especially this one. This parentheses right here is necessary to do log of 17 first, and then have your calculator divided by log of 3. And my answer is 2.5789. Now let's see, where does it want me to round? It wants me to round to the nearest thousandth, so that's 3 decimals. So to the third decimal, 1, 2, 3. This is the third one. Since the next number is 5 or greater, I'm going to round this up. So it's going to be 2.57, and then this is going to be a 9. So b is equal to, or it's approximately 2.579. And then I'm just going to check it right here. It's a different color. Let's check it. So 3 to the something. Does 3 to the 2.579? I'm curious what that equals. So 3 to the 2.579, and I should get 17. Let's see. Hey, look at that. It is 17. So we're good. Okay, that's it. One more thing I'm going to show you down here. Number 7. What do you think we're going to do here? Well, here's my exponent, right? I'm trying to get the exponent alone. So the first thing I need to do, I want to isolate the exponent. So just like a normal equation, I'm going to subtract 3 from both sides. This cancels. I get 9 to the n plus